we are going to learn how to find the Fourier series of such function where the function is divided into two parts. Like in this case, overall the interval is minus pi to pi, but from minus pi to 0 the function value is 0, whereas from 0 to pi the function value is sin x. Before finding the Fourier series, let's observe how the graph of this function looks like. From minus pi to 0, function value is 0, and from 0 to pi, function is sin x. From 0 to pi, the function sin x will look like this way. This is a graphical view of this function. Now we are writing the Fourier series. It means this function is a periodic. If this function is periodic, what is the period? So that is the length of the interval. Pi minus minus pi, that is 2 pi. It means after the period of 2 pi, we have same function. So it means from pi to 2 pi, the function value is 0, and from 0 to 3 pi the function value is sin x, and similarly on the left hand side. Let's write the Fourier series of this function starting with the interval. So we have the interval from minus pi to pi. As per this one, the value of a is minus pi and the value of b is pi. And what is b minus a? That is the length of the interval, 2 pi. Now Fourier series is equal to a naught by 2 plus summation n from 1 to infinity an, and with an we are taking a cos term, 2n pi x divided by length of the interval, that is 2 pi, plus summation n from 1 to infinity bn sine of 2n pi x divided by length of the interval, that is 2 pi. The simplified form is equal to a naught by 2 summation n from 1 to infinity an cos of nx plus summation n from 1 to infinity of bn into sine of n into x, where a naught is calculated as 2 upon length of the interval, that is 2 pi, integration from minus pi to pi f of x with respect to x, and an is calculated as 2 upon 2 pi, integration from minus pi to pi. This is basically length of the interval. So function multiplied by cos of nx integration with respect to x, whereas bn is calculated as 2 by length of the interval, integration from minus pi to pi function into sin nx integration with respect to x. Function is basically defined as, according to this, we need to split this integration in order to evaluate a naught, an and bn. So let's calculate a naught first. So a naught is equal to 1 upon pi integration from minus pi to pi of the function with respect to x. This is equal to 1 by pi as it is. Split this integration because the function is divided into two parts. So one is from minus pi to 0, function value is 0, plus then 0 to pi, function value is sin x. Find its integration. So integration of 0 is 0. So we will directly write this is equal to 0. Finally, we have 1 upon pi integration of sin s minus cos of x, limit from 0 to pi. This is equal to 1 upon pi with negative sign outside. Substitute upper limit, that is cos of pi, minus lower limit cos of 0. This is equal to minus 1 upon pi. Cos of pi is minus 1. Cos of 0 is 1. So this is equal to 2 upon pi. So in this case, the value of a naught is equal to 2 by pi. Now let's find the value of an and bn. Next, calculate an. So an is equal to 2 upon length of the interval, that is 2 pi. Integration from minus pi to pi of the function into cos of n into x. This is equal to 1 upon pi. So split this integration into two parts because the function is divided into piecewise form. So minus pi to 0, the function value is 0 into cos of nx plus 0 to pi, function value is sin x, cos of nx, integration with respect to x. So this quantity is 0 because integration of 0 is 0. So we have in this case 1 upon pi integration from 0 to pi of sin x into cos of nx with respect to x. In this case, we cannot use the islet because neither the derivative of sine is getting 0 nor cos derivative. Whenever we have such situation, we are going to use the trigonometric formula. So here we can use 2 sine A cos B form. That is equal to sine of A plus B plus sine of A minus B. So we need to create 2 over here in order to apply this formula. So multiply by 2 and divide by 2. So this is equal to 1 upon 2 pi integration from 0 to pi 2 sine x cos nx. So according to this, the value of A is equal to x and the value of B is nx. So A plus B means x plus nx. A minus B is x minus nx. We can take x common from here. We have 1 plus n into x and over here 1 minus n into x. So use this form and in this case we have sine of a plus b, that is 1 plus n into x plus sine of 1 minus n into x. Its integration with respect to x. Integration of sine is minus cos. So in this case, the integration of this term is minus cos of 1 plus n into x divided by 1 plus n. And here integration is minus cos of 1 minus n into x divided by the coefficient of x, that is 1 minus n. Limits are 0 to pi. We can also write this as minus 1 by 2 pi cos of 1 plus n into x divided by 1 plus n plus cos of 1 minus n into x divided by 1 minus n. In this step, we have taken negative sign outside. Now substitute the upper limit and lower limit. So this is equal to minus 1 upon 2 pi cos of 1 plus n in place of x pi divided by 1 plus n plus cos of 1 minus n in place of x pi divided by 1 minus n. That is the value of upper limit minus lower limit. When you substitute x is equal to 0, we have cos 0 and cos 0 is 1. So 1 upon 1 plus n plus 1 upon 1 minus n. This is equal to minus 1 by 2 pi. What is the value of cos 1 plus n into pi? Since we know that cos of n pi is equal to minus 1 raised to power n, the value of cos of 1 plus n into pi, that is equal to minus 1 raised to power 1 plus n, whereas cos of 1 minus n into pi is minus 1 raised to power 1 minus n. Use these values over here and the final expression is minus 1 raised to power 1 plus n divided by 1 plus n plus, in this case, minus 1 raised to power 1 minus n divided by 1 minus n minus 1 upon 1 plus n, negative positive, it is a negative of 1 upon 1 minus n. This is further is equal to minus 1 upon 2 pi, club these two terms, that is minus 1 raised to power 1 plus n minus 1 upon 1 plus n plus minus 1 raised to power 1 minus n minus 1 upon 1 minus n. That is a combination of these two terms. Now observe that whether we are getting the values of every an starting from the 1 means can you obtain the value of a1, a2, a3, a4 and so on from this expression? Clearly observe this expression. This expression is defined for every value of n except 1. Why not for the 1? If we take n is equal to 1, in this case what we have? Minus 1 upon 2 pi minus 1 raised to power 1 plus 1 is 2 minus 1 upon 1 plus 1 plus minus 1 raised to power 1 minus 1 upon 1 minus 1. This is equal to minus 1 by 2 pi. Numerator term is 0 because minus 1 square is 1 and 1 minus 1 is 0 divided by 2 plus minus 1 raised to power 0 is 1. 1 minus 1 is 0 and even in the bottom we have 1 minus 1. So it is a 0 by 0 form and here that term is undefined. It means with the help of this expression we cannot calculate the value of a1. So in such cases what we need to do, go back to the value of a and in this case substitute n is equal to 1. Either substitute n is equal to 1 in this case or in this case or in this case. Before finding the integration you can substitute n is equal to 1 in any of these steps. We have an is equal to 2 by 2 pi integration from 0 to pi sine of x into cos of n into x. Basically we have taken this form. Substitute n is equal to 1. We have a1 is equal to 2 by 2 pi integration from 0 to pi sine of x cos of n into x, that is n is 1, that is simply cos x. Now this is equal to 1 by 2 pi. If you club 2 over here, so 2 sine x cos x, that is equal to sine 2x. So we can write here as a sine 2x integration with respect to x and the limits are 0 to pi. This is equal to 1 upon 2 pi integration of sine 2x is minus cos 2x divided by 2. Upper limit is pi and lower limit is 0. This is further is equal to minus 1 upon 4 pi. Substitute upper limit in this function. We have cos of 2 pi minus, put x is equal to 0. We have cos of 0. This is equal to minus 1 upon 4 pi. Cos 2 pi is 1 minus cos 0 1. From here we are getting the value of a1 is equal to 0. From here let's calculate the value of a2 and a3. So for that what we need to do, we will split this part into even and odd. When n is even and when n is odd. Because we have minus 1 raised to power something minus 1. So definitely Either at a even this quantity is 0, or for odd it is getting a 0. So we can get the simplified form in this case. Let's observe that. Suppose n is even. So if n is even, what we have? An is equal to minus 1 upon 2 minus 1 raised to power. If n is even, this quantity is odd. 1 plus even is odd. Minus 1 upon 1 plus n. Keep this n as it is, because with the help of even, maybe 2, maybe 4, this quantity is changed. But this quantity is always minus 1 raised to power odd. Plus minus 1 raised to power. When n is even, we have 1 minus even number, suppose 2. In that case, if n is 2, in that case the answer is minus 1. If we take n is equal to 4, we have minus 3. If we take n is equal to 6, we have minus 5. So these quantities are odd. So we can say that negative of odd minus 1 upon 1 minus n. Minus 1 raised to power odd or minus 1 raised to power minus odd. That is always is equal to minus 1. So we can write this as is equal to minus 1 upon 2 pi minus 1 upon 1 plus n plus minus 1 upon 1 minus n. This is equal to minus 1 upon 2 pi minus 2 upon 1 plus n plus minus 2 upon 1 minus n. Take minus 2 outside, we have 2 upon 2 pi 1 upon 1 plus n plus 1 upon 1 minus n. This is equal to 1 by pi. Simplify this, we have 2 upon 1 minus n square. So whenever n is even, in that case the answer is 2 by pi 1 minus n square. Now when n is odd, what we have? In case of odd, this quantity is even and this quantity is also even but negative of even. Minus 1 raised to power even, that is always 1, and in this case minus 1 raised to power minus 1, again 1. 1 minus 1 is 0, and even in the next term we are getting a 0 in the numerator. Overall answer we are getting in this case as a 0. So whenever the n is even, in that case an is equal to this, and when n is odd, provided n is not is equal to 1, we are getting answer 0. Even we have separately calculated that a1 is equal to 0. So it means we can take that n is odd with 1, 3, 5 and so on. In that case an is 0. Next is calculate bn. The value of bn is calculated as 2 upon length of the interval, that is 2 pi, integration from minus pi to pi of the function into sine of n into x with respect to x. So this is equal to 1 upon pi. Split this integration into two parts. One is from minus pi to 0 and second is from 0 to pi. In case of minus pi to 0, the function is 0. So 0 into something is 0. Plus, in this case, the function is sine of x into sine of n into x. Integration of 0 is 0. So we have in this case 1 upon pi integration from 0 to pi of sine x into sine of nx with respect to x. In this case, we cannot use the Eilert form because in this case, sine x or sine nx is not getting 0 for any derivative. In such cases, we are using the trigonometric formulas. In this case, we are using the form as 2 sine A sine B, that is equal to cos of A minus B minus cos of A plus B. A in this case is x and B is n into x. So we are going to use this form, and we have 1 upon pi 0 to pi cos of a minus b, that is 1 minus n into x, minus cos of a plus b, that is 1 plus n into x. Integration with respect to x. This is equal to 1 upon pi. Integration of cos term is sine 1 minus n into x divided by 1 minus n, minus, again in this case integration is a sine 1 plus n into x divided by 1 plus n, and the limits are 0 to pi. Now observe this function at upper limit and lower limit. Sine 1 minus n into pi. Sine n pi is 0, so it means this is also 0. Even sine 1 plus n into pi is 0. When you substitute lower limit, we have sine 0 and sine 0 is again 0. It means these two terms are getting 0 on upper limit as well as lower limit. So we can say that the value of Bn is equal to 0. Before saying that, you just need to check whether that is well defined for every value of n greater than equal to 1. As in this case, this function is getting 0 for every n greater than 1, not is equal to 1. Because when you take n is equal to 1, in this case we have sine of 1 minus 1 is 0, 0 into x is 0, divided by 1 minus 1, that is 0. So sine 0 is 0. So we are getting 0 by 0 form, and that is undefined. It means in this case again we need to calculate b1 separately. So how to calculate b1 from here? So you can write this as is equal to 1 upon pi 0 to pi sine x, put n is equal to 1, that is again sine x, so we are getting a sine square, integrate with respect to x. In order to integrate this one, what we need to do, we need to convert this in form of cos 2x form. So we know that cos 2x is equal to 1 minus twice of sine square x. From here the value of sine square is 1 minus cos 2x divided by 2. So we have 1 upon pi, integration from 0 to pi, 1 minus cos of 2x divided by 2, its integration with respect to x. So this is equal to 1 by 2 pi. Integration of 1 is x, minus integration of cos 2x is, that is sine 2x divided by 2. Lower limit is 0, upper limit is 0. So when you put pi in this term, we have sine 2 pi and sine 2 pi is 0. Same when you put 0, sine 0 is 0. It means this term is getting 0 for both the limits. So we can write this is equal to 0. So this is further is equal to 1 by 2 pi. Substitute upper limit in this case, pi, pi minus 0. Simplify this, this is equal to 1 by 2. So the value of V1 in this case is 1 by 2, whereas Bn is 0 for every n greater than 1. Till now we have calculated A0, An and Bn. Now we are going to write the Fourier series expansion. So from here we can write this as equal to A0 by 2 plus, expand this. So we have in this case a1 into cos of x by substituting n is equal to 1, then plus a2 cos of 2x for n is equal to 2, plus a3 cos of 3x for n is equal to 3, a4 cos of 4x plus a5 cos of 5x, and so on. Plus, for this case we have b1 sine of x plus b2 sine of 2x for n is equal to 2, then b3 sine of 3x, and so on. Substitute the values of a naught, an, and bn in this case. So a naught is equal to 2 by pi. So we can write this as equal to 1 by pi because that 2 is get cancelled with 2, plus a1 means n is odd. In that case, the answer is 0. From here, we can write this value as 0 because a1 is 0, even a3 is 0, even a5 is 0. And from here, b2, b3, b4, all terms are 0. So we can, this is equal to 0, this is equal to 0. So finally, we have a2 is equal to 2 by pi 1 minus 2 square, substitute n is equal to 2 in this case, cos of 2x, plus a4 is 2 by pi 1 upon 1 minus 4 square cos of 4x. Next term is for n is equal to 6, so that is 2 upon pi 1 upon 1 minus 6 square cos of 6x, and so on, plus the value of b1 is half, so we can write this is half of sine of x. This can further simplified as 1 upon pi, club this term first, 1 by 2 sine of x. From here, 2 by pi is a common term, so we can take 2 by pi outside. This is 1 upon 1 minus 2 square cos of 2x, plus 1 upon 1 minus 4 square cos of 4x, plus 1 upon 1 minus 6 square cos of 6x, and so on. Now we can write this in form of summation. In this case, we have cos of 2x, cos of 4x, then cos of 6x, and then as cos of 8x. And here we have 2, 4, 6. These numbers are even. So this can be written as summation. N starts from 1 to infinity because infinite terms are there. 1 upon 1 minus 2n square, because this is an even quantity. When you put n is equal to 1, it is a 2. When you put 2, 4. When you put n is equal to 3, we have a 6. N is equal to 4, next term is a 8. Even in this case, we can write cos of 2nx. And these terms are as it is. This is the final Fourier series for this case. The next question is, show that this series is equal to 1 by 4 into pi minus 2 with the help of the Fourier series obtained in the same question. So we have this Fourier series. From here we need to reduce this expression. So if you observe that in denominator we have 1 into 3, 3 into 5, 5 into 7. This term can be obtained if it is depending upon n, because this is the infinite series, and that is summation we have only in this case. It means we cannot make this point as a 0. So we need to choose a x in such a way that we can remove cos factor and this quantity is non-zero. Why we need to remove cos factor? Because we don't need cos factor in this series. So we need a finite value of cos. And if you observe in this series, we have positive, negative terms. Right now, according to this Fourier series, we are not getting minus 1 raised to power n. So it means we need to find a x such that this term results minus 1 raised to power n. Now the point is we need to find the angle of cos such that that is equal to minus 1 raised to power n. And this is only possible when we have n into pi. It means we need to create this is into n pi. Now for what value of x we have n pi in this case, that is for pi by 2. If you put x is equal to pi by 2, 2n into x, that is equal to 2n into pi by 2. So 2 is get cancelled with 2, we have n pi. So it means if we put x is equal to pi by 2, we need to check whether we are having this series or not. Let's try to find this expansion with the help of pi by 2. So put x is equal to pi by 2 in Fourier series. So when you put x is equal to pi by 2, we have function at pi by 2. This is equal to 1 by pi plus 1 by 2 sine pi by 2 is 1 plus 2 by pi summation starts from 1 to infinity 1 upon 1 minus 2n square. This is cos of n pi after substituting x is equal to pi by 2, and that is equal to minus 1 raised to power n. Now the point is, what is the function value at pi by 2? For that we will deal with the original function. So where pi by 2 lies? So pi by 2 lies in this range, and in this range function is defined as a sin x. So for x is equal to pi by 2, function value is sin pi by 2, and that is equal to 1. So substituting the function, so function is sin at x is equal to pi by 2 is equal to 1 by pi plus 1 by 2 plus 2 by pi. Now before expanding, observe this factor and the required series. In the required series, we need 1 into 3, then 3 into 5, then 5 into 7. So we need two different values. So can you create this 1 into 2 factor? Yes, because it can be written as a square minus b square. So over here, rather than expanding, first we will write it in form of a minus b into a plus b, and this minus 1 raised to power n as it is. This can further written as sin pi by 2 as 1. Take this term on a left hand side. So we have minus 1 by pi minus 1 by 2. This is equal to 2 by pi. Now expand this. N is equal to 1. So we have minus 1 into 3, and here minus 1 raised to power 1 plus n is equal to 2. 1 upon 1 minus 2 into 2, that is minus 3 into 5, and here minus 1 square plus n is equal to 3. 1 upon minus 5 into 7 minus 1 raised to power 3, and so on. So this term is equal to pi minus 2 upon 2 pi, that is equal to 2 pi into this negative sign is get cancelled with this one. So we have 1 upon 1 into 3, and here we have positive sign and here we have negative sign. So overall answer is a negative of 1 upon 3 into 5. Here we have a negative sign and even here we have a negative sign. So overall answer is a positive times of 1 upon 5 into 7, so on. Here this pi is get cancelled with pi. So we can write this as pi minus 2 by 4 is equal to 1 by 1 into 3 minus 1 upon 3 into 5 plus 1 by 5 into 7 minus so on. So that is the required series in this case.